Hey guys, welcome back to 13.1. In this video, we're going to be talking about the graph of the sine function. So we've been talking about sine. We know that it's opposite over hypotenuse when we have a right triangle. And we know that it corresponds with y on the unit circle. But what does it look like if we just graph sine? So we're going to start at negative 2 pi. I know there's a 0 there, but we're not starting at 0. We're starting at negative 2 pi. And then we're going to go to 2 pi. So we're not going to be covering all of these points, but actually, we are going to start at 0. We are going to do the negative side, but on the table, we're just going to go from 0 to 2 pi, and then I'm going to show you the symmetry to do the negative half. So we are going to start at 0. And so at 0, if we remember from our unit circle, 0 in radians is the positive x-axis, which means y is also 0. So y is 0. And then the next one we're going to do is pi over 4. That's our 45-degree angle. So sine of pi over 4 is square root of 2 over 2. And we're going to get a decimal approximation for that to graph it because that's kind of meaningless, right? When we graph something, we kind of need a decimal in order to know what we're supposed to graph. So square root of 2 over 2 is approximately 0.71. It's 0.707, and then it just keeps going. I'm just going to approximate it at 0.71 for our purposes. So the next thing we have is pi over 2. That's our 90-degree angle. So 90, remember, is the positive y-axis, so that's going to be 1 on our unit circle. And then 3 pi over 4, 3 pi over 4. That's going to be our 45-degree angle in quadrant 2. So sine is going to be positive in quadrant 2. Remember, all students take calculus, so sine is positive in quadrant 2, so that's going to be square root of 2 over 2 again, or 0.71. And then at pi, that's going to be our negative x-axis, so again, y is going to be 0. 5 pi over 4 is in the third quadrant, 45-degree angle. Sine is negative, so that's negative 0.71. Notice the symmetry here. We're basically just having all the same numbers, just going between positive and negative. And then 3 pi over 2. So that's the negative y-axis, so it's going to be negative 1. Remember, sine corresponds with y, so that's negative 1. Sine of 3 pi over 2. Sorry, I lost my place. 3 pi over 2. 7 pi over 4 is next. 7 pi over 4 is going to be, again, 45 degrees, fourth quadrant this time. So sine is again negative. And it's not negative 1, though. It's negative 0.71. And then we have 2 pi. So we're back to the same location as 0. So that's just going to be 0, positive x-axis. All right. So graphing that, we're going to start here at 0. We have 0. And then we're going to have 0.71. So we're just below this 0.75, right? 0.71. And then 1. back to 0.71, so same height as the last one, back to 0, down to negative 0.71, down to negative 1, back up to negative 0.71, and then back up to 0. All right, so it looks like this. And then it's going to keep going. I'm actually not going to put an arrow because an arrow would imply that it goes off to infinity. It doesn't. It doesn't stop either. It actually continues to make the same shape over and over again, and we're going to talk about that. But first, I want to talk about what happens when the angle is negative. So looking at our unit circle, this is the positive direction. The negative direction, if we go down from the x-axis, this is the negative direction. So the negative, so say negative 30, for example, would be the same thing as 330, just going in the opposite direction. So negative 45 would be 350, the same as 315. So we're just going this way around the circle. So negative pi over 4 is again negative 45, so we'd be down here. So sine is going to be negative square root of 2 over 2, and then negative 1, negative square root of 2 over 2, 0, positive square root of 2 over 2, 1, positive square root of 2 over 2, back to 0. So that's what we're doing. So we're basically doing, instead of going this direction down what we have written, essentially we're going that direction, right? We're going to go from 0. Remember, 2 pi is the same thing as 0. We're going to go that way. We're going negative. So we were at 0, and we're going to go negative 0.71, negative 1, negative 0.71, 0, positive 0.71, positive 1, negative 0.71, positive 0.71, back to 0. So we have this shape. So notice, if we kept going in either direction, we just keep going around and around and around and around and around the unit circle. So I keep wanting to put an arrow. Don't put an arrow. We would want, so essentially this keeps making this shape over and over again. And notice the repetition. So we have this shape and then it repeats and we do it again. So every time it repeats, that's called a period. So a period is when it repeats. So period is every time it repeats. So you could look at a period as going from trough to trough. We call this, or minimum, I should say, from minimum to minimum. We could look at it as going from maximum to maximum. That's a period. So any time where you can start anywhere, essentially you could start anywhere. Minimum to minimum and maximum to maximum are the easiest ways to define a period. But it's anywhere the whole thing starts repeating again. So if I started here, it'd be a weird place to start, but I would go like this, and then, it starts repeating again. So I'd stop here. That's one period away from here. And so it's going to be the same distance. So if you look at what distance is this, it's actually 2 pi. A period for sine that doesn't have any transformations on it is going to be 2 pi. So this distance is 2 pi. This distance is 2 pi. This distance from here to here, and it starts over again, you can easily see that that's 2 pi. So this would start the process over again. So that's a period, is where it starts to repeat. Yeah. So anytime it starts repeating, that's going to be a period. You could have a funky thing where it goes and it doesn't quite come back, and then it does. So the period would be where it wouldn't be this maximum to this maximum, it'd be this maximum to this maximum, because it's where the pattern starts over again. So whatever pattern is happening in your graph, the period is where the pattern starts over again. The other thing I want to talk about is amplitude. Amplitude is the distance from the midline to a minimum or a maximum, or it's the half the distance between a maximum and a minimum. So the midline in this case is just the x-axis. It goes through the middle of the graph. That's why it's called the midline. It goes through the middle of the graph. So the amplitude is the distance. Yeah, do a different color so that I'm not confusing things. Is the distance from the midline to the maximum, or the midline to the minimum, which is the same distance. So you can also think of it as half the distance from here to here, right? Because if I cut this distance in half, I'd get this distance and that distance. So the amplitude is kind of the height. And it's max minus min divided by 2. So it's half the distance between these two, which in this case is 1, right? This, even though it's not well drawn, is up here at 1. And this is down here at 1, or negative 1. So this distance is 1. This distance is also 1. So in this case, the amplitude is 1. And again, if sine doesn't have any transformations on it, the amplitude is going to be 1. But in general, the amplitude is the maximum minus the minimum divided by 2. Which in this case, the maximum is 1, the minimum is negative 1, so 1 minus negative 1 is 2, divided by 2 is 1. The amplitude is in fact 1. So that works out. All right, so that's all I wanted to talk about with sine functions. Hopefully this video isn't as horrifically long as some of the other ones have been. Yeah, so let me know if you have any questions, and I will see you in the next video when I talk about cosine.